to talk about the Turkey earthquake, what are the causes and what impact it can do on the people of Turkey as well as on the Syrian people. So today I will cover all these topics and this live streaming. I hope you may enjoy it and watch it till the end. So today I'm very happy, and I hope you also be happy that the world who are being helping to the Turkey, they are sending the army, they are sending rescue team, they are sending medicines to the Turkey. That is what which is very better thing that the people of the world are doing today. And even I have heard that the uh, worldwide, like US, India, Pakistan, Afghanistan, Syria, not Syria, um, US, UK, Africa, and even Saudi Arabia, and these all countries are helping to the Turkey and Syria, and this is what which is the best thing. So today I'm going to cover all these topics, so I hope you may enjoy it. Number first thing is earthquakes. Earthquakes are among the most deadly natural hazards. There are around 100 earthquakes each year of a size that could cause serious damage. They strike without warning, and many of the Earth's earthquake zones coincide with areas of high population density. When large earthquakes occur in such areas, the results can be catastrophic, with terrible loss of human lives and untold economic cost. So, what is an earthquake? An earthquake is the sudden release of strain energy in the Earth's crust, resulting in waves of shaking that radiate outwards from the earthquake source. When stresses in the crust exceed the strength of the rock, it breaks along lines of weakness, either a pre existing or new fault plane. The point where an earthquake starts is termed the focus or hypocenter and may be many kilometers deep within the earth. The point at the surface directly above the focus is called the earthquake epicenter. So this was about the earthquake. Now there is also the next intensive vibrations or seismic waves spread out from the initial point of rupture, the focus, like ripples on a pond. These waves are what makes the ground shake and can travel large distances in all directions. Near the focus, the waves can be very large, making them extremely destructive. BGS earthquake monitoring. The BGS earthquake seismology team is the UK's national earthquake monitoring agency. We operate a network of sensors across the UK to measure earthquakes in the British Isles and around the world. We use the data we collect to investigate the nature and distribution of earthquake activity and what makes them happen, to improve our understanding of earthquake hazards. Recent earthquake data feeds. Earthquake around the British Isles last 50 days. Induced seismicity around the British Isles last 50 days. Significant world earthquakes last 200 days. Online data feeds, GeoRSS and kilometer. So this was about the earthquake. Now I would come to the causes of earthquakes. What causes earthquakes? The causes of earthquakes and the different types of tectonic boundaries and faults on which they usually occur. What are these? So I'm going to share all these things with you people. I hope you may like it. Now, earthquakes are the result of sudden movement along faults within the earth. The movement releases stored up elastic strain energy in the form of seismic waves, which propagate through the earth and cause the ground surface to shake. Such movement on the faults is generally a response to long term deformation and the buildup of stress. This is what is the earthquake causes earthquakes. What causes earthquakes? Now, the structure of the earth. What is the structure of the earth? You may not know about it. So today I'm going to also share about the Earth structure. Seismic waves from large earthquakes pass throughout the Earth. These waves contain vital information about the internal structure of the Earth. As seismic waves pass through the Earth, they are refracted or bent like rays of light bend with when they pass through a glass prism. Because the speed of the seismic waves depends on density, we can use the travel time of seismic waves to map change in density with depth and show that the Earth is composed of several layers. Now this was the structure of the Earth. So I'm going to explain and deep these all structures of the Earth. The first one is the crust, the second one is the mantle, and the last one is the core. And the core, we are having two types. So one is the inner, the next one is the outer core. So the first one is the crust. So this brittle outermost layer varies in thickness from about 25 to 70 kilometer under continents and from about 5 to 10 kilometer under the oceans. Continental crust is quite complex in nature and is made from many different kinds of rocks. So this was about the crust. You know that the crust is deep is 25 to 70 kilometer, and if you're checking it in the oceans, it is under 5 to 10 kilometer under the ocean. This is what the length of the or the thickness of the crust, while it mostly varies on the kinds of rocks. These types of things are included in this layer of the earth. The second one is the mantle. Below the crust lies the dense mantle extending to a depth of 2890 km. It consists of dense silicate rocks. Both P and S waves from earthquakes travel through the mantle, demonstrating that it is solid. However, there is separate evidence that parts of the mantle behaves as a bell fluid over very long geological time scales, with rocks flowing slowly in giant convection cells. And so this was the mantle. Now I would come to the core. At a depth of about 2,900 km is the boundary between the mantle and the Earth's core. The core is composed of iron. It is composed of iron, and we know that it exists because it refracts seismic waves, creating a shadow zone at distances between 103 and 143. We also know that the outer part of the core is liquid because S waves do not pass through it. So this was about the layer of the earthquake. Now I would come to the plate tectonics. What are plate tectonics? The Earth's outermost layer is fragmented into about 15 major slabs called tectonic plates. These slabs from the lithosphere, which is comprised of the crust, continental and oceanic, and the upper part of the mantle, tectonic plates move very slowly relative to each other, typically a few centimeters per year, but this still causes a huge amount of deformation at the plate boundaries, which in turn results in earthquakes. Observations show that the most earthquakes are associated with tectonic plate boundaries, and the theory of plate tectonics can be used to provide a simplified explanation of the global distribution of earthquakes. While some of the characteristics of earthquakes can be explained by using a simple elastic rebound theory. Now, what drives the movement of tectonic plates? This is very important, and you should know about this. Below the tectonic plates lies the Earth's asthenosphere. The asthenosphere, the asthenosphere behaves like a fluid over very long time scales. There are a number of competing theories that attempt to explain what drives the movement of tectonic plates. Uh, the three of the forces that have been proposed as the main drives of tectonic plate movement are mental convection currents, warm mantle currents drive and carry plates of lithosphere along like a conveyor belt. And this was the first. Number second is a ridge push beyond upwelling mantle at mid-ocean ridges. Newly formed plates at oceanic ridges are warm, so they have a higher elevation at the oceanic ridge than the colder, more dense plate material further away. Gravity causes the higher plate at the ridge to push away the lithosphere that lies further from the ridge. Slab pull older, colder plates sink at the subduction zones because as they cool, they become more dense than the underlying mantle and the collar. Sinking plate pulls the rest of the warmer plate along behind it. Now, research has shown that the major driving force for most plate movement is slab pull, because the plates with more of their edges being subducted are the faster moving ones. However, push is also presented in recent research to be a force that drives the movement of plates. Now, I would come to the types of plate boundary, and this is also important. You should know about the plates of the earth. That what are plates? I think the plates are near to 20, and the earth. The plates are the pieces of the earth. So these pieces rotate under the earth and the earth. So therefore, you should know about these plates or these pieces of the earth. There are three types of plated boundary. Number first is divergent. So this divergent plates moving apart. Number second is convergent. This plates moving together. So transform is the third one, and it says that plates moving past each other is the transform. Now boundaries between tectonic plates are made up of a system of faults. Each type of boundary is associated with one of three basic types of fault called normal, reverse, and strike slip faults. So now I would come to the divergent boundary. What is it? So plates can move apart at a boundary. This type of boundary is called a divergent boundary. It is also referred to as a constructive plate boundary as new material is being produced at the boundary surface. This type of boundary is dominated by normal faulting, although other types of faulting may be observed. Now, a divergent or constructive plate boundary where new material is produced at the surface. The mid Atlantic ridge is a good example of a constructive plate boundary. You can see normal faulting at the surface where the mid Atlantic ridge crosses island. Now, hot magma rises from the mantle at mid ocean ridges, pushing the plates apart. Earthquakes occur along the fractures that appear as the plates moving apart. Examples include the East African Rift and mid-ocean ridges where two ocean plates are moving apart, such as the regions near the Azores and Ireland. Divergent boundaries are associated with volcanic activity, and the earthquakes and their zones tend to be frequent and small. Now, the second one is convergent boundary. Convergent boundary is continental collisions result in the creation of mountains and fold belts as the rocks are forced upwards. Plates can move together. Plates can move towards each other at a boundary. This type of boundary is called a convergent boundary and is dominated by reverse faulting, although other types of faulting may be observed. A convergent or destructive boundary showing subduction of an oceanic plate under a continental plate. When the boundary is between an oceanic plate and a continental plate, it is also referred to as a destructive plate boundary. At subduction zones, the oceanic plate is pushed down or subducted below the continental lithosphere. As the oceanic slab descends, earthquakes are generated within the slab and at the interface between the plates. Destructive plate boundaries include deep ocean trenches like the Peru-Chile Trench, where the Nazca Plate and Oceanic Plate is being subducted under the South American continental plate. Therefore, the Oceanic Plate is forced underneath the continental plate. These boundaries tend to be produce most of the earthquakes that have magnitudes greater than 6.0. Subduction zones also produce the deepest earthquakes, where the boundary is between two continental plates. One plate crumbles crumples upwards over the other instead of one plate being subducted. Examples include the boundary between the Eurasian plate and the African plate, forming the Alps, and the boundary between the Indian plate and the Eurasian plate, where the Himalayas are formed, where the Eurasian plate is forced up and over the Indian plate. This type of boundary tends to produce a diffuse zone of activity. Continental collisions result in the creation of mountains and fold belts as the rocks are forced upwards. A convergent boundary showing mountain formation where one continental plate crumples up and over another continental plate. Reverse faults or thrust faults are found at convergent boundaries. They are associated with mountain ranges such as the Himalayas or the Alps. Now the third one is transform boundary. So plates can move past each other in the same plane at a boundary. This type of boundary is called a transform boundary. This type of boundary is dominated by strike slip faulting, although other types of faulting may be observed. Where two plates slide past each other, earthquakes or originate at shallow depths. This type of plate boundary is also referred to as a conservative plate boundary, as it involves movement but no loss or creation of material at the surface. Examples include the San Andreas Fault in the USA and the Anatolian Fault in Asia Minor. A transform boundary where two plates slide past each other in the same plane. Strike slip faults occur at transform boundaries. For example, a system of strike slip faults makes up the transform boundary of the San Andreas Fault. Transform boundaries typically produce large, shallow focus earthquakes. Although earthquakes do occur in the central regions of plates, these regions do not usually have large earthquakes. Elastic rebound theory. Elastic rebound theory was originally proposed after the Great San Francisco earthquake in 1906 by the geologist Henry Fielding Reid to explain the deformation caused by earthquakes. Before an earthquake, the build-up of stress in the rocks on either side of a fault results in gradual deformation. Eventually, this deformation exceeds the frictional force holding the rocks together and sudden slip occurs along the fault. This releases the accumulated stress and the rocks on either side of the fault return to their original shape, elastic rebound, but are offset on either side of the fault. Now, there are the types of fault. There are three basic types of fault: normal, reverse, and strike slip. Certain types of fault Certain types of fault are characteristic of different plate boundaries, although often more than one type of fault uh, occurs there. This can help us understand the relative movement of the plates and the type of deformation. So, number first is normal fault, second is reverse, and third one is strike slip fault. So, now normal fault is what? It is a normal fault. The block above the fault moves down relative to the block below the fault. Now, the reverse fault. In a reverse fault, the block above the fault moves up relative to the block below the fault. Strike slip fault. During an earthquake, the rock on the side on one side the rock on the one side of the fault suddenly slips with respect to the other. The fault surface can be horizontal or vertical or some arbitrary arbitrary angle in between. Faults are classified using the angle of the fault with respect to the surface known as the dip and the direction of slip along the fault. Faults that move along the direction of the dip plane, while strike slip faults are classified as either right lateral or left lateral. Faults when Faults which show both dip slip and strike slip motion are known as oblique slip faults. Now, I would come to the earthquake. s- The second one I would love to talk is earth hazards. So that is important. Yeah, I should come to the earth hazards. So, natural hazards such as earthquakes, volcanoes, and landslides can occur without warning and cause damage to health, homes, and livelihoods. The earth beneath our feet is constantly shifting and moving, sometimes ever so slowly, but sometimes swiftly and violently with catastrophic and immediate results. We are living on an active planet and we cannot stop these events occurring, but learning more about why, how, and where they happen can help us to be more separated. Now, I would come to the I think we should come to the volcanoes. What causes the volcanoes? Now, there are more than 1500 active volcanoes on Earth. How many? 1500 volcanoes are active right now in the Earth or on the Earth, not in Earth, we can say on the Earth. Around 50 to 70 volcanoes erupt every year. Every year, there are 82 volcanoes in Europe, and 32 of these are in Ireland, one of the UK's closest volcanic neighbors. Most of the volcanoes on Earth are not well monitored or even monitored at all. Some volcanoes erupt almost continuously, therefore Etna and Stromboli, but some do not erupt for tens, hundreds, or even thousands of years. Why does BGS study volcanoes? We have a team of volcanologists that works on various research projects and locations around the world. This research helps governments and local people too understand the signals that may indicate an eruption will happen soon, understand different volcanoes' personalities and behavior, understand the potential hazards posed by volcanoes, work with work with communities living near volcanoes and further afield to try and reduce risk from volcanic eruptions. Understand how best to take advantage of volcanic systems, therefore geothermal energy. The BGS volcanology team works with government agencies to provide support and scientific advice not only during volcano unrest or changes from a volcano's normal state, but also in preparation for potential future activity. Find Now I would come to how volcanoes form. So, how volcanoes form? This section looks at the relationship between plates tectonics, earthquakes, and volcanoes, which helps to explain how volcanoes form. If you look at a map showing the distribution of earthquakes around the world, it shows that they tend to be concentrated along well defined belts. Correspondingly, maps of tectonic plate boundaries are primarily produced using earthquake locations. We can also see from the distribution of volcanoes around the world the most lie on plate boundaries too, in particular a region called the Pacific Ring of Fire around the edge of the Pacific Plate. Now, the tectonic plates are in conflict with each other, but they are also moving relative to one another. The movement of faults at plate boundaries can provide a convenient pathway for magma to reach the surface. It helps to explain this by looking at the three main types of plate boundary. Constructive boundaries divergent where plates are moving away from each other as new crust is created between the two plates. Destructive boundaries convergent where plates are moving towards each other and old crust is either dragged down into the mantle at a subduction zone or pushed upwards to form mountain ranges. Transform boundaries conservative where our plates are moving past each other and crust is neither created or destroyed. Cross section of the earth, and now there are three settings where volcanoes typically form, and these are constructive plate boundaries, destructive plate boundaries, and the last one is hot spots. Now, volcanoes do not typically occur at transform boundaries. One of the reasons for this is that there is little or no magma available at the plate boundary. Now, constructive plate boundary volcanoes. At constructive plate boundaries, the tectonic plates are moving away from one another. The Earth's crust is pulled apart to create a new pathway for rising hot magma to flow on to the surface. Volcanoes can sometimes form in this setting. One example is island. Island lies on the mid-Atlantic ridge, a constructive plate boundary where the North American and Eurasian plates are moving away from each other. As the plates pull apart, molten rock magma rises up and erupts as lava, creating new ocean crust. The island is covered with more than 100 volcanoes. Some are extinct, but over 30 are still active. The majority of volcanism an island occurs along volcanic rift zones that cut through the center of the island. Note: island also sits above a mantle plum or hot spot where hot magma wells up from deep in the Earth's mantle. The interaction of these two types of volcanism over the last 15 million years or more has created the island of Iceland. Destructive plate boundary volcanoes. Destructive or convergent plate boundaries are where the tectonic plates are moving towards each other. Volcanoes form here in two settings oceanic plate destructive where either oceanic plate descends below another oceanic plate or an oceanic plate descends below a continental plate. This process is called subduction and creates distinctive types of volcanoes depending on the setting. Ocean continent subduction produces Andine type volcanoes. Subduction provides a mechanism for introducing water bearing sediments into the mantle as the subduced oceanic plate sinks and heats up. Water is gradually released from the sediments and minerals within the plate slab. Water has the effect of reducing the melting temperature of the mantle but above by about 60 to 100 centigrade. It is this process that allows the generation of magma at depth that feeds volcanoes that are formed at the surface. Note: there is a third setting of destructive boundary continent continent. Here are the pushing together of two continental plates results in the mountain forming processes that shaped, for example, the Alps and Himalayas. Hotspot volcanoes. Volcanoes can also form above a column of superheated magma called a mantle plume. This may happen in areas that are distant from plate boundaries. It is also referred to as hot spot of entrepelate volcanism. Heat from the mantle plume causes melting and thinning of the crust, which leads to volcanic activity at the surface. The Hawaiian Islands are a chain of volcanoes in the middle of the Pacific plate which have formed due to the presence of a hot spot. The Hawaiian hotspot causes magma to rise and erupt as lava on the ocean floor. Over millions of years, the Pacific plate has moved over the hotspot, creating a chain of volcanic islands. Now, I would come to discovering geology. So, I think you have listened to it, and you may have known about the plates, the types of fault, and all things. Now, I would come to the discovering geology. So, discovering geology introduces a range of geoscience topics to school age students. and learners of all ages explore these pages to discover these fascinating processes and properties that shape our dynamic planet. So, the Earth has been cooling down since it formed 4.6 billion years ago. Over that time, its surface has changed constantly, driven by the movement of magma deep within the planet and aided by the processes of erosion, deposition, and weathering. New oceans have appeared as tectonic plates move apart. Great mountain ranges have formed as tectonic plates crash together. Valleys have been created as glaciers move, and the wind has carried sediment particles on over great distances to form new landscapes. Discovering geology explores the processes that have shaped current and past landscapes and how our planet's diverse range of rocks and minerals formed. We also investigate how rocks and fossils can be used to explain the changing climates of the past and why learning from the past is the key to understanding our sustainable future. Throughout discovering geology, we link topics with the scientific research and monitoring work that we carry out at the BGS. From investigating natural earth hazards to understanding past environments, our research aims to offer geoscientific solutions for a safer, more sustainable, and prosperous planet. Now, discovering geologic climate change. Now, I will talk about the climate change. What is the difference between weather and climate? This is very necessary. So, weather describes the combination of wind, rain, temperature, and other natural atmospheric conditions. We experience at a particular time and place. So, climate is the pattern of weather of an area averaged over many years. So, what is the difference between climate and weather? You got that the weather is the combination of wind, rain, temperature. That is natural atmospheric conditions, and we experience it as once in a place. While the climate is the pattern of weather that occurs in an area for many years. So that is what is the climate, and weather is only for sometimes in one region. So if we have extremes in weather conditions, such as a long summer drought or a very cold winter, it doesn't necessarily mean that the climate is changing. We can only show whether climate change has occurred after decades or careful measurements and analysis. The climate system. We can see from the diagram that the climate system has many components that interact with each other. A change in one component may alter the operation of another. The effects of changes are often dependent on the operation of feedback mechanisms. A feedback that enhances an initial change in climate is positive, but those that decreases the size of the change are negative. For example, if the amount of solar energy observed on the Earth's surface were to increase, then the surface temperature would increase. This would lead to a decrease in the amount of snow cover. Snow reflects more solar energy than land vegetation or water. So, a decrease in the amount of land covered by snow would allow more solar radiation to be observed, and so a positive feedback is initiated. Now, would come to the carbon story. I think it may be funny. So, let's see. The amount of carbon we have on Earth doesn't change, and this is what is scientifically proof. It is the same as it is now, as it was millions of years ago when the dinosaurs roamed the earth. Most carbon is stored in reservoirs or sinks, such as rocks and sediments, while the rest is stored in the atmosphere, oceans, and living organisms. Carbon is released back into the atmosphere through respiration by animals and plants. It is also released by burning materials such as wood, oil, and gas. Such this is called the carbon cycle. So the carbon cycle is what? A carbon is a crucial element for all life on Earth. Carbon is the basic building block of life and helps form the bodies of living organisms. It compounds, form solids, liquids, and gases. Now, carbon may be either organic or inorganic. Organic carbon is found in living or dead organisms, fossil fuels, small deposits in rocks, dissolved in water, dispersed in the atmosphere. The majority of the inorganic carbon exists is carbon dioxide, carbonate, and hydrogen carbonate. There is a continuous two-way flow of carbon between the organic and inorganic forms. Inorganic carbon is found in what it is known as an oxidized state, which is reduced to organic carbon during photosynthesis. Organic carbon can be oxidized by atmospheric oxygen, usually through respiration breathing. The energy released during respiration is used both by planets and animals to maintain their bodily functions. A similar process in which oxygen cycles between the atmosphere, the earth, and living organisms interlinks with the carbon cycle. And photosynthesis, the process plants use to produce energy from their food, and respiration are central to both. More than 99% of the carbon in the carbon cycle is found in the Earth's crust. Most of this has a biological origin, deposited on the ocean floor from the remains of the many marine creatures that use calcium carbonate in their skeletons and shells. After consolidation, these deposits may form a rock known as limestone. Now, I would come to the carbon dioxide levels in the atmosphere. Now, carbon dioxide is a gas that contains carbon and oxygen. It has twice as much oxygen as carbon and is often written as CO2 for short. CO2 levels in the atmosphere depend on the balance between CO2 sources and sinks. Sources give out CO2 and sinks absorb and store CO2. Geological source of CO2, carbon dioxide in the atmosphere are volcanoes, gases escaping from the Earth's mantle, erosion of rocks containing carbon such as limestone. By contrast, By contrast, the erosion of silicate rocks is a process that tends to remove carbon dioxide from the atmosphere. Rainwater is slightly acidic because it incorporates carbon dioxide from the atmosphere. The result of this rain falling on silicate rocks is the formation of chemicals called bicarbonates, which are washed into the oceans and eventually incorporated into the mantle through the process of subduction. Volcanoes can increase CO2 in the atmosphere. Volcanism, which much greater during the middle part of the Cretaceous period, around 100 million years ago, which is why CO2 levels in the atmosphere were much higher then, resulting in a much warmer climate. Methane hydrates. Methane is a gas that is composed of carbon and hydrogen. It contains four times as much hydrogen as carbon and can be written as CH4. It is actually a much more powerful greenhouse gas, the CO2, but is less concentrated in the atmosphere. There is a large amount of CH4 frozen into a type of ice called methane hydrate, which is found in permafrost, which is ground that remains frozen throughout the year. The structure of methane hydrate holds molecules of CH4 much closer together than if they were in their gaseous form. This means that solid methane hydrate can potentially hold a lot of CH4 gas. There is a large quantity of CH4 below the seafloor and permafrost soils. Methane in these reservoirs can be released by processes like temperature changes or disturbing the sediment as a result of submarine landslides. Now, the amount of methane hydrate in which permafrost soils is poorly known, with estimates ranging from 7.5 to 400 gigatons of carbon. If all this methane hydrate were to melt, there could be a catastrophic, catastrophic changes to our climate. Methane hydrates are a component of the uh, cryosphere. Anywhere on Earth where water is in solid form is known as the cryo cryosphere. This includes snow, ice, and permanently frozen ground. These all play different roles within the climate system. For example, the continental ice sheets of Antarctica and Greenland activity influence global climate over geological time scales, but they may also have more rapid effects on sea level. Changes in the uh, cryosphere are connected to global scale feedbacks, including solar reflectivity and ocean circulation. Now, this was what we discovered about the carbon story and methane. Now, I would come to the what are we doing about the climate change? So, it is also important, and we should know about it. That what are the bad things, or what are the causes that we make climate, and why it happens because of us. This is very important, and we should know about it. So this is what is live streaming, and I'm going to explain all these things. You don't worry about it. So I'm going to explain this thing, that what are we doing about climate change? What are our responsibility about it? So BGS is committed to research that we will help produce in innovative solutions aimed at slowing down the effects of a rapidly changing climate w- whilst helping society to become resilient and adapt to climate change. Research areas. How can we reduce our carbon emissions through better use of our energy resources? This is the first question. How can geoscience help society to adapt and become more resilient to environmental change? Second number. Number third is how can we adapt and become more resilient to hazardous processes such as landslides and flooding, which affect people and property? This is the third question. So, better use of energy resources, reducing and removing CO2 from power production, heat transport, and industry, also known as decarbonization, is a major challenge for society. The BGS is investigating the feasibility of different technologies for decarbonization and how society better manages natural resources. Our research is split into several areas: disposal of radioactive waste and carbon capture and storage, energy storage, innovative use of the underground to store energy such as compressed air, clean power, shallow and deep geothermal sources, and the offshore setting of wind farms and tidal barrages, metal and materials. Understanding the resources needed for a low carbon world. Now, the next one I should come is what are the impacts of climate change? This is also important. I have to explain this one also. So, consequences of global temperature rise. So, to predicting the consequences of global warming is one of the most difficult tasks for the world's climate researchers. The natural processes that cause rain, hail, and snow, storms, increases in sea level, and other expected effects of global warming and are dependent on many different factors. It is also difficult to predict the size of the emissions of greenhouse gases in the coming decades, as this can be influenced by political decisions and, and technological advancements. Many of the effects of global warming have been well documented, and observations from real life are consistent with predictions. Now, what will be affected by temperature rise? Number first is agriculture. Different crops demand different conditions to grow. Even within a country like Britain, crops such as apples grow better in some places than in others. This regional variation is often down to different local conditions, including climate. If temperature rise, some crops may become harder to cultivate and may have to be replaced with ones more suited to the new environment. Now, frequency of extreme weather incidents. In the future, a warmer climate may cause more heat waves, increases rainfall, and increases the frequency and strength of storms over the past 35 years. There has been an almost five-fold increases in the recorded number of disasters caused by natural hazards, although not all were influenced by extreme weather events. So, the number of global reported disasters caused by natural hazards since 1900. This includes those from drought, floods, extreme weather, extreme temperature, landslides, dry mass movements, wildfires, volcanic activity, and earthquakes. Overall, deaths from natural hazards have been a large decline over the past century, but meteorological, hydrological, and climatological events have increased since 1990. That is why that it has been increased since 1980. That is the source or word in data is that as the earth warms up, interactions between the oceans and atmosphere can amplify the frequency and intensity of weather events. These include hurricanes, floods, and droughts. Extra water vapor in the atmosphere falls again as extra rain, which can cause flooding. During hot weather, evaporation from both land and sea increases and can cause droughts in regions where there is low precipitation. Now, quantity of ice and snow. Worldwide, glaciers are shrinking rapidly and ice appears Muxara. Worldwide glaciers are shrinking rapidly and ice appears to be melting faster than previously estimated. And areas dependent on meltwater from mountains changes in water flow and availability can lead to a lack of water and even drought. According to the Intergovernmental Panel on Climate Change, up to a sixth of the world's population lives in areas that will be affected by meltwater reduction. In some regions of the world, this will result in crop failure and famine, especially in areas where temperatures are already high. Now, towns and villages that are dependent on meltwater from mountain areas may suffer a drought and lack of domestic water supply. Now, sea levels. Increased levels of ice and snow melt cause sea levels to rise, as does thermal expansion. Water expands when warmed. Areas that lie just above sea level now where one day become submerged. For example, some Pacific island nations are expected to be partially or completely submerged by the end of the 21st century. As a rise in sea levels will also have an impact on coastal and shallow marine planets. Shallow marine plants and animals will be affected. For example, mangroves and coral reefs and countries with large areas of coastal lowland, there will be a dual risk of river floods and coastal flooding, which will reduce the area for living and working. Coastal defenses will need strengthening and river leaves will require developing. An increase in standing water may potentially increase populations of insects like mosquitoes and therefore malaria and other diseases that are associated with standing water such as Lyme's decrease. Such as Lyme's disease. So, wildlife will respond to climatic changes in different ways. Certain species might be able to adapt or migrate to habitats with more suitable conditions where species are unable to adapt and conditions become inhospitable, populations are likely to become threatened and in extreme cases species may face extinction. In 2019, a UN report suggested that around 1 million animal and plant species would be threatened with extinction, many within decades and more than ever before in human history. Now, past climates. How do we know about the different climates that Britain has experienced in the past? Geologists find evidence in all the sorts of places. Types of evidence rocks. So the characteristics of different rocks depend on the environment in which the sediments that formed them were deposited. Some sands and gravels are deposited by retreating glaciers and they become a distinctive sediment called till. Where till is found, we know that there must once have been glaciers and therefore a cold climate. Rocks that form in a hot desert environment are often colored red by iron deposits. In regions with high temperatures, water can evaporate quickly, leaving behind a layer of salt on the ground that becomes preserved in the rocks and is another indicator of a hot climate. Sandstone colored red with iron oxides indicating a hot climate at the time of deposition. Now, fossils. Different species of plants and animals need different conditions to survive. Some can be very sensitive and do not adapt easily to change. For example, reefs live in tropical waters within a particular temperature range, specific depths, and require certain high levels. If water conditions change even by a relative small amount, they cannot survive. Therefore, wherever fossil corals are found, it is possible to estimate the environment in which they lived in the past because of these specific environmental requirements. Now, the next one I would love is to talk about greenhouse earth evidence. Naturally induced global warming has occurred in the past. The Earth has a natural mechanism for dealing with this problem, but it is one that unmankind cannot rely on to solve the current crisis. Towards the end of the Cretaceous period, 100 to 66 million years ago, the Earth experienced extreme levels of marine volcanic activity. Huge amounts of lava erupted at the fractured boundaries of the tectonic plates running beneath the Pacific and Atlantic Oceans. Elsewhere, usually large accumulations of molten basalt had erupted through these plates, forming large areas of thickened oceanic crust known as ocean plateaus. Volcanic gases released by these eruptions were rich in carbon dioxide, CO2, and sulfur dioxide, SO2, and although some CO2 was absorbed by the oceans, much found its way into the atmosphere. Analysis of fossil soil horizons and fossil plant remains suggests that late Cretaceous atmospheric CO2 levels peaked between 4 and 18 times current levels. So, this was all about that I said to you. Now, I would love to talk about something new, and, and therefore, I would talk that. So, this was what I talk about, and I hope you may have listen to it and you may have understand what I said. And right now I am going to talk on the results of all the things, and also I would talk about the Turkey and Syria. That what was the basic things that impact and effect on the people of Turkey and Syria, and as well as on the world people. All these things will be covered by me today in this live streaming. I hope you may learn something in this and you may get information in this. So, everyone who is watching, thank you so much. I really appreciate, I really love you all. Now, this is how do earthquakes affect people. Now, how do earthquakes affect people? Over the centuries, some towns and cities have repeatedly been struck and sometimes devastated by major earthquakes. The difference between damage and devastation depends not only on the magnitude of the earth but also on local geology and building techniques. How earthquakes affect buildings. This is the first important thing that we should know. Why the buildings are devastated and what can it affected by. So ground conditions, number first thing. Soft ground based mostly on sediments such as those in floodplains, reclaimed land or former landfill amplifies the effect of the earthquake vibrations, while harder rocks limit the amount of shaking. This effect, this effect contributed to the huge amounts of damage caused in the 1906 San Francisco earthquake. So in the 1923 Kanto Tokyo earthquake, Tokyo earthquake and the 1985 Mexico City earthquake. For example, in some cases, the land may even liquefy, behaving like quicksand and causing buildings to sink or topple over. Now, building design and construction is also important. So, poor construction technique where slab walls and flowers are not tied together correctly, for example, makes buildings for more vulnerable to earthquake damage. Buildings where the bricks have been held in place with the correct mortar tend to survive much better. However, there is more to the issue of building design than simplify the difference between careful and shoddy construction. Now, this was what that impact. That was the effect of earthquake on the people, and I said about this that it depends also on the houses and buildings, how they are built, how they are constructed, and why they should be devastated. So all things I said about it, and now I would come to the Turkey earthquake. I'm going to search the latest news about it. So I'm searching about it and I will share it with you people. I hope you may get about it. So this is what that I am sharing now. I am going to have a look on it because I need the latest news which are being shared right now. So now, I would come to the news, what they are saying. So I am searching and I am investigating about it. The way I get, the way I will share it with you people. So now, what the news says about the Turkey and Syria earthquake. This is very important, and you must know about it. That what is happening around you and what is happening in the world, because it is our need, and we must know about it. So the first thing I would say is that not only one country but the whole world is helping Turkey and Syria, and we are with them and we will help them, and even what type of materials or medicines, whatever they need, we have to help them, and we should manage all these things for them, and we should have to help them all the time. Not only Turkey, even if anywhere a sudden natural disaster happens, we must help them, and there is the UN who are being doing the same thing, and UN can control and they can help easily. So right now I'm going to search the news. So I'm talking about news, and this is the news. So Turkey earthquake highlights death toll crosses 12,000. One Indian missing, 10 stuck in remote parts. Now, Turkey Syria earthquake news highlights. So, while the death toll rose above 9,000 in Turkey alone, while in Syria the toll climbed to more than 2,500 overnight. So it becomes more than 13,000 both by the Turkey and Syria. The Reuters reported said the number of people killed is likely to go up. Therefore, they can go up because most of the people they are under the ground and the buildings they are being devastated. So the rescue team they are helping. So Turkey Syria earthquake highlights says that Turkey's president Recep Tayyip Erdogan is visiting quake hit areas as anger mounts among the people over the as anger mounts among the people over the slow and inadequate response by authorities. This is very important because the Tayyip Erdogan, who is the president of Turkey, he has been late and he is lacking to arrive to the causes areas which are being devastated. Mostly, he is slowing. So therefore, the people are very angry to them, to his authorities. So the death toll from the quakes in Turkey and Syria together has crossed 12,000. 10 Indians who are struck in remote quake hit parts are reported safe. This is about the India who were stuck. They are safe right now. Now I would come that one Indian citizen is missing. The Ministry of External Affairs said the government is in touch with the missing person's family. Rescue workers are still struggling to reach some of the worst hit areas. They are held back by destroyed roads, poor weather, and a lack of resources and heavy equipment. They fear the toll may go up even higher in the hours ahead. This is, I can't believe how they are going slow. They should be faster. Uh, the people of the world they're also helping, and most of the governments have sent their army to help them because one country cannot do it. There are many people who are being under the ground and they are near to death, and they are seeing the death in front of them that the death will come to them. So therefore, the world needs to help them. Many of the survivors also fear there could be a deaths due to cold and hunger. Yeah, this is the thing. This is the point. Because if you are under the building and it is cold and you don't have to eat, of course you have to die because of hunger and even because of the cold. Now Tayyip Erdogan acknowledged earthquake relief problems as death toll passes 12,000. President Tayyip Erdogan on Wednesday admitted there were problems with his government's initial response to a devastating earthquake in northern and southern Turkey amid anger from those left destitute and frustrated over the slow arrival of rescue teams. Tayyip Erdogan, who contests an election in May, said on a visit to the disaster zone that operations were now working normally and promised no one would be left homeless. As the combined reported death toll across Turkey and neighboring Syria rose past 12,000 and 13,000, reports by Reuters. Across a swath of southern Turkey, people sought temporary shelter and food and freezing winter weather and waited in anguish by piles of rubble where family and friends might still lie buried. Impossible. It is a very sad news. Rescuers were still finding some people alive, but many Turks have complained of a lack of equipment. This is the thing, yeah. Expertise and support to rescue those trapped, sometimes even as they could hear cries for help. Now, in earthquake hit Turkey, there are also Pakistani who are being under the buildings. Even there are other countries, people who are being hit by this Turkey earthquake and Syria earthquake. Right now, WHO sending medics and supplies to Turkey and Syria earthquake zone. The World Health Organization is deploying expert teams and fights with medical supplies to Turkey and Syria after Monday's devastating earthquake. It will send a high-level delegation to coordinate its responsive as well as three flights were medical supplies, one of which is already on its way to Istanbul. WHO Director General Tedros Adhanom told a media briefing on Wednesday. The health needs are tremendous, said Dr. Iman Shanketi, the WHO representative for Syria. The combined death toll in the two countries is currently more than 11,000 people. WHO officials have previously estimated that the toll may reach more than 20,000 deaths after the disaster. So many thousands are also injured. The doctor said that, adding that the Syrian healthcare system was already on its knees after years of war. In Turkey, WHO representative Bitter said more than 53,000 people were injured, and aftershocks are continuing as well as trauma kits. WHO Emergencies Director Mike Ryan said that mental health support was also critical for survivors. As well as supporting other ongoing medical needs, WHO has released $3 million for its initial response. So, Turkey police detains at least 18 people, arrests 5 over provocative posts on social media. The Turkish police arrested 5 and detained at least 18 people for what was described as provocative posts on social media about Turkey's deadly earthquake, according to a tweet from the force. So this is also very important. We should not share such wrong information with the people. We should be careful. So now the people of the Turkey, they are saying that we will die because of hunger. With the hope of finding survivors, stretched rescue teams in Turkey and Syria are searching for signs of life in the rubble of thousands of buildings toppled by a catastrophic earthquake. The confirmed death toll from the world's deadliest quake in more than a decade past 11,000. So this is what is happening right now in the Turkey and Syria, and it is impossible that the people are dying because of hunger. There should be a quick rescue team uh, taking action, and they should help. And the same the people are doing. They are moving to the Turkey. The army of different countries, they are moving to the Turkey, as well as the medicines are being exported to the Turkey, and all the countries are working together to help Turkey and to cover all the dead bodies, as well as to rescue all the injured people, because most of the people, they are disturbed because of the earthquake that is being in the Turkey. And you know that the Turkey earthquake, it happened more than 3 times in Turkey. The first one was near to 7.8 magnitude, the second one was near to 6.6 magnitude, while the third one was near to 5.6 magnitude uh, earthquake. So this was the earthquake that happened in Turkey and Syria, and this is going to happen in Pakistan, India, and Afghanistan also. The prediction about Pakistan, India, and Afghanistan is that earthquake will occur in next 6 days. So it is going to devastate a lot of buildings, same in these countries. But we are praying that God may bless us and Allah may bless us and give us long life. And people, thank you, and this live stream as well as